Welcome back. This is the next section of work. It's on the operation of sets. And we have quite a few topics to deal with in this section, so let's get going. The first definition is what a universal set is. A universal set is a set which contains all of the elements under consideration. The symbol epsilon or U can be used to denote the universal set. A universal set may be an infinite set or a finite set. Let's look at this example. The universal set could be the numbers 1 to 10, and these are positive integers or natural numbers. And we'll define set A as the natural numbers between 4 and 7. So set A are the natural numbers between 4 and 7 inclusive. So we include the n numbers 4, 5, 6, and 7. Okay, then we draw a Venn diagram here. And we only have one set A, so we draw one circle. And we put the numbers that we have, 4, 5, 6, 7, into the circle. And the remaining numbers from the universe go outside the set. Okay, so 1, 2, 3, 8, 9, 10. So this is set A, which is defined here. And then the universal set are all numbers, including the numbers that are inside the set. Okay, but this here is what is called the complement of a set. So look at this definition. They are the numbers which are members of the universe and not a member of A. Okay, so not a member of A. So they're in the universe, but not a member of A. So in this case, A prime would be the numbers outside. 1, 2, 3, 8, 9, 10. So 1, 2, 3, 8, 9, 10. This is called the complement of A, the complement of A. And some textbook, especially Thai textbook, use AC. So AC and A prime mean the same thing, okay? So this is what we had, the complement of A, 1, 2, 3, 8, 9, 10. And let's note this here. So the number in the universe is 10 elements. The number in A is 4. And the number in not A, the complement of A, is 6. Okay. One property of the complementary sets is that the number in the universe is the sum of the number in the set plus the number that are not in the set. So in the set, we had 4 elements here, and the number not in the set was 6, and they should add up to be 10. As shown there. So this is one way to check you've done the work correctly. So these are some exercises to try. I want you to write down the complementary set of C. C are the vowels. What are not the vowels? So if you know the vowels are A, E, I, O, U, you need to write down the letters which are not the vowels. So B, C, etc. You need to write them all down in roster form there. Okay, you can have a go at those questions. They're all about complement of a set. Okay, the next section is on the intersection of sets. Intersection means where the sets have common elements. And the symbol for that is A intersect B. It's an upside down symbol here. So any element which is common to both that is written inside here. And the definition of intersection, X is a member of A and a member of B. So it must be in both sets. And the area we're interested in is here, the overlap between the two sets. Let's look at a question. So we're given a universe, which are numbers 1 to 10. Set A is 1, 2, 3, 6, 7. Set B is 2, 3, A, 10. And we need to draw a Venn diagram first. Venn diagram is very useful for answering these kinds of problems. So we'll draw a Venn diagram, A and B here. It doesn't matter which one A and B, so A and B. Now, which elements are in the middle that are shared between both sets? So we can have a 2, we have 3, and that's it. So we would write 2 and 3 in here. Okay, so what elements are in A but are not in B? So 2 and 3 are in B, but then there's 1, 6, 7, which are in A. So 1, 6, 7. So in A completely, it's 1, 2, 3, 6, 7. So these elements are also in A and they're also in B. So if we look at B, the 2, 3 is already here. So we have two elements to write in, 8 and 10. Okay, so look which elements you have. We've got 1, 2, 3, 6, 7, 8, 10. Okay, so what elements would you write outside? So which numbers are in the universe but are not in the sets? So we've got 1, 2, 3. What's missing? 4, 5, 6, 7, 8, 9. So 4, 5, and 9 are outside the sets. So 4, 5, 9. You can write them wherever you want. Okay, so find the complementary sets. So these are the elements which are not in A. Which elements are not in A? 4, 5, 9, 8, 10. These ones here. These are not in A. They can be in B, that's fine, as long as they're not in A. So 4, 5, 8, 9, 10. So 4, 5, 8, 9, 10. So which elements are not in B? So B is here. So which elements are not in this set here? There must be 1, 4, 5, 6, 7, 9. 1, 4, 5, 6, 7, 9. It's a good idea to put them in order if you can, like that. So these are all the elements that are not in B. These ones here, there. So just avoid going in B. Remember, this center is also B. Now this is find the intersection between A and B. So which elements are in both? So this means in both sets. It's just an upside down U. So that is only 2 and 3. 2 and 3. So this one, let's think about this here. The intersection of A and not B. So let's draw D out again. Because drawing and shading Venn diagrams is very important for what you need to do in future. So this is set A and set B. So where does A intersect not B? So what I'll do, I mark A is here in green. So this is set A. Where is set not B? So I want to shade in not B. So I'll use a shader. Not B is all here. That is not B. So go around not B. Okay. So again, A is this area here. And not B is in yellow. Now, where do these two areas overlap? Where do they touch? It's going to be only this part here, right? So A only. So if we go and look at our diagram, That is only 1, 6, and 7. Okay, so the answer for that one is 1, 6, 7. Okay, so let's practice the next picture. Do that again. So make a Venn diagram, A and B. So now find not A intersecting B. So where is not A? Not A is in blue here. Not A. So you can go into B, I just don't want to go into A. So not A. So avoid going into A, but you can go everywhere else. Okay, where does that touch B? So we'll do B in yellow. Here, B. This is all of B here. So that's B in yellow. So where do they intersect? Where are they touching? You see, that must only be this area here where they overlap. So on your diagram here, that would only be elements 8 and 10. Okay, so that would be 8 and 10. Like that. So how about this question here? N means, remember, cardinal number. So how many elements are in the intersection of A and B? And remember, A and B is here. So there are only 2 elements, so that equals 2. Okay, we'll get more practice on Venn diagrams soon. Another concept you need to know are disjoint sets. So disjoint sets, they have no elements in common. So for example, we can have 1, 3, 5, 7 as X and Y, 2, 4, 6, 8. So these sets are disjoint, okay, because they have no elements that are the same. Notice that? And when we draw that picture, we have 2 sets which are separated. They don't touch because they have no elements in common. So 1, 3, 5, 7 for X and Y is 2, 4, 6, 8. And they have a gap. They're separated. So we could write the intersection of X and Y is empty. It's an empty set. Or remember, we can use that empty brackets for an empty set as well. So for an example, we've got sets 1, 2, 3, 4, 2, 4, 6, 8, 3, 5, 7, 9. Which pairs of sets are not disjoint and which pairs are disjoint? So which ones share element? Notice that A and B have 2 and 4. So A and B are not disjoint. So these 2 sets are touching with element 2 and element 4. What else do we have? 2, 4, 6, 8, 3, 5, 7, 9. These are completely different numbers, aren't they? So B and C are disjoint. Joint, joining. So disjoint means not joining. And what else do we have? A, B, B, C. What about AC? 1, 2, 3, 4, 3, 5, 7, 9. Well, here they share 3. They share element 3. So A and C are not disjoint. So think about what that picture would look like. So A and B are touching. Let's draw A and B. A has 1, 2, 3, 4. So we've got 2 and 4. 2 and 4 here. A has 1 and 3. But C is shared with A, the set C. C has 3, A has 3. And this has 5, 7, 9 as the remaining numbers. The other elements in B, 2, 4, were 6 and 8. So I guess if you were going to draw your Venn diagram, it would look something like that. There's a few exercises to do. Okay, we can do one together. Okay, we need to shade the following regions in the given Venn diagrams. So look at what you have. You have A. So I recommend when you do this, use one color and go this way. When you do the other one, use a different color and go that way. So for set A, where is set A? Everywhere, including the bit that's in B. So this is set A and not B. So you need to shade in everything that is not B. But go in the other direction, otherwise you may confuse the two sets of lines. So not B, do not go in B. And don't go in B. Okay. Now this symbol, intersection, means where your two lines are going to be intersecting. Okay. And if you look at your picture, that is only this area of A only. So in your final solution, you color in only that area. You can rub all the other lines out because you don't need them. Right, so that purple area, this would be your solution. That's your shaded area for that area. Okay, so try the other ones doing the same method. What about this one? A intersect B, but not that. So not A intersect B. Well, A intersect B is here, isn't it? So you need to shade everything that is not that. So not A intersect B. A intersect B is in red here. So not that would be everywhere around that. Okay, so in yellow there, that's your solution. And you should rub out the extra working here for the lines. You don't need that. Question 2, so find the intersection of the sets. We've got A and B. So you just write out the elements. A intersect B, what are they? So which elements are the same? You can see 0, you can see 4, etc. Some questions are written in set builder notation. This symbol here with a line is the same as the 2 dots that you saw earlier. It means such that. So you may want to review about your set builder notation before you start these ones. Okay. You can help yourself with drawing Venn diagrams as well. Okay, so these are your questions to do. These are some multiple choice questions. So you probably should show the working on the side here about how to do these problems, how you got your solution. Okay, good luck with that, and I will be happy to see your work come in on time.